Let's go ahead and take a look at the next question. In problem number 22, they want us to solve the rational equation. The first thing we need to do on a problem of this type is, first of all, look for the list of restrictions, which would be any places where our denominators would be equal to 0. If I take the first denominator and set it equal to 0, we directly get the value x equals to 0. When I set the second denominator equal to 0, we solve and we get the value x equals to negative 4. So we have two restricted values in this case. They are going to be 0 and negative 4. The next thing we want to do is get rid of the fractions by multiplying every single term by the GCD of our denominators. With the denominator of x and x plus 4, the GCD would be x times x plus 4. So that's what we're going to multiply each fraction by. So I'm going to multiply the first fraction by x times x plus 4. And I'm going to multiply the second fraction by x times x plus 4. Good, you can think of over 1 if it helps. For the first one, the x's are going to cancel, and that's going to leave me with x plus 4 times x minus 4. On the right hand side, the x plus 4's cancel, and I just get 15 times x, which is 15x. So our fractions are gone. I can FOIL out the left-hand side, or just notice that it's like the factorization of a difference of squares. That's going to be x squared minus 16, if you multiply it out, equals to 15x. Because of the x squared term, this is going to be a quadratic, so we want to get one side to be 0. So I'm going to subtract 15x from both sides. That gives us x squared minus 15x minus 16 equals to 0. We would now want to factor this. This factors as x minus 16 times x plus 1 equals to 0. We now go ahead and set each factor equal to 0. The first one would tell us that x equals to 16. The second factor would tell us that x equals to negative 1. Before we get too excited or circle these, you have to double check to make sure that neither of those numbers appears on the list of restrictions. The only restricted values we had were 0 and negative 4, which tells us that these should both check out. So we get two solutions, x equals 16 and x equals negative 1. Let's take a look at the next one. Again, we want to solve this rational equation, so we should first find our restrictions. The two denominators we have are x and x plus 2. So I set each one of them equal to 0 and solve. And we get two values, 0 and negative 2. So those are going to be our restricted values. We next identify the GCD. The GCD of x and x plus 2 is going to be x times x plus 2. So that's the term we're going to multiply every single term in the equation by. So I'm going to come over here, I'm going to multiply the first one times x plus 2 times x plus 2 times x plus 2. For the first term, x times x plus 2 times 3, I can think of it as x times 3, which will give me 3x, and then I can distribute the 3x into the parenthesis. 3x times x is 3x squared. 3x times a positive 2 would give me 6x. Over here, the x's cancel, and so I'm left with a negative 2 times x plus 2. And on the right-hand side, think of it over 1. The x plus 2's cancel, and I have 3x times x, which is going to be 3x squared. We can simplify the left-hand side. We have 3x squared plus 6x. Distribute the negative 2 in. It's going to give us a negative 2x minus 4 equals to 3x squared. It looks at its heart to be like a quadratic equation. Let's just simplify these two middle terms here. That'd be a positive 4x minus 4. Because of the x squared, we should get one side to 0. So we subtract 3x squared from both sides. They actually turn out to cancel, and we're simply left with 4x minus 4 equals 0. It's a basic linear equation. We add 4, and then divide by 4. and we get the proposed solution x equals 2 to 1. We just had to, again, be very careful. Go back and check. The only restricted values we had were x0 and -2. That was neither one of the values, so that will work out. So we have the solution x equals to 1. We'll do one more of these. Here we just have one unique denominator that pops up. That's x minus 10. X minus 10 equals 0 precisely when x equals to 10. So our restricted value is going to be x is 10. The GCD is going to be that x minus 10 term. So we're going to multiply every single term in the equation by x minus 10 times x minus 10 times x minus 10. Here these cancel, so we just get 1 times x, which is x. Here I can distribute the -6 in to get -6x plus 60. And over here the x minus 10s cancel again, and I get just 10. We want to solve this. I have -5x plus 60 equals to 10. Subtract 60 from both sides. -5x equals to -50. Divide by -5. Divide by -5. And we get the proposed solution x equals 2 to 10. This time, if we check, 10 was actually one of our restricted values. So what that means is that this value will not work in our equation. This is what's sometimes referred to as an extraneous solution. Even though we call it an extraneous solution, it's really not a solution at all. So for 24, we had one proposed answer, which was x equals to 10, but unfortunately that number will not work, so our final conclusion would be that there is no solution.